Hi Stats class, this is a problem for 8.5 homework set, and we are conducting a hypothesis test about a standard deviation. And we've got the first part set up here. If you read it carefully, it says test the claim that this method produces errors with a standard deviation greater than 32.32. So that's what we're wanting to test. So we put a quality in the null hypothesis, and because we're testing for it to be greater, we got a greater than symbol in the alternate hypothesis. Okay, so once we got that setup done, with StatCrunch, remember with standard deviations, our option in StatCrunch is to use the variance stats, one sample, and with data. So we click that, and hypothesis test. Now, you have to remember that there's several other videos where I've talked about this. When we do this chi-square stuff and the test and the confidence intervals for the standard deviation, you got to remember that we got to use variance. So we got to square these numbers. So 32.2 has to be squared when we plug it in here, because we have to treat this like it's variance. So that's what's going to go in right here. So that was 1036.84. Right? And then we want the alternate hypothesis, again, remember, was greater than. So we want greater than, and then we will compute it. Now, the test statistic, the p-value, all that stuff is the same as it would have been if we go through the methods that it would say in a given example. So there's the chi-square test statistic. Move this over so we actually see it. The chi-square test statistic to 2 decimal places is 35.37, and the p-value is, oh no, sorry, it's critical values. So for critical values, we need, let me open up StatCrunch again. Alright, so I exit out of the hypothesis test. I'll have to go back into it just a second, but to get the critical values, you're going to come into stat calculators. This is chi-square, right, and then I'll move this over so we can see. We got our degrees of freedom was 11, one less than this. Number of samples, so there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the degrees of freedom is one less than that. And this is a right-tailed test, so we want greater than. I'm going to delete this. And then over here is our level of significance. So in the right tail, we want 0.05 as our level of significance. So we want 0.05 in the right tail. When I hit compute, it'll tell me the number that has that for that degrees of freedom. So 19.675, how many places? 2 decimal places, so 19.68. There's only one because it's a right-tailed test. Alright, so the test statistic is well beyond the critical value. So since the test statistic is greater than the critical value, we reject H0 because there is sufficient evidence to support. Okay, when we again draw that picture now, instead of a bell curve illustrating what we're doing here, it's chi-square, so it's not a bell curve. It's a chi-square curve, which is like a right skewed distribution. So now we're like this, right? And so in the right tail, we got that area is 0.05, right? That's the level of significance. That's alpha. Right, the number that cut that off, according to what we saw here, was the 19.68. That's the number down here. And the number that we conducted from our data set was way up here, 35. What was it again? 35.37. So I'm going to put it 35.4. But it's way up here. And remember, this is also called the rejection region. Is another name, and what I would even actually prefer you call it because it lets us know that if we're in this area, if we're in this tail, if our test statistic falls there, then we'll reject the claim. So because that's why we're rejecting H0. Okay. The second part is having us interpret what the results of our tests tell us. All right. So because the standard deviation, the population standard deviation has gotten bigger, the variation appears to be greater than it was in the past. So the new method appears to be worse, because there will be more altimeters that have errors. Therefore, the company should take immediate action. Okay, so because this is bigger, it's greater than it was, greater than 32.2, significantly greater because of the fact that we rejected it. It looks like things are getting worse, and the standard deviation is increasing.